In this tutorial, I'll be going over how to make a very simple neural network in Python and train it on some data that we'll create to determine whether the price of an item is considered cheap or expensive. This tutorial will be extremely simple and to the point, and the output won't be very useful, but it will go over the basics of training neural networks and defining layers to classify data. Now you might be wondering, what exactly is a neural network? It's really just a method inspired by the human brain that mimics how neurons signal to one another. And this is pretty much the base of what any deep learning, machine learning, or modern day AI is using. Now we have an idea of what's going on inside neural networks, but not exactly specifics of what it's doing. We can build code that simulates neurons and classifies images or generates sentences, but we don't know exactly the details of why it outputs the way it does or why it functions how it does. And this is mainly due to the fact that once these networks are trained, they become extremely complex and dense. So to summarize, neural networks are neurons with connections, and these connections have weights, and these weights determine what info gets passed along from one neuron to another, or the importance of the connection, and these connections overall affect the final decision or prediction or output of the neural network. Now, before we start jumping into the code on how to create these neural networks, we're going to make sure that we have a few models installed in Python. So we'll have to make sure that we have Tensorflow installed, and Tensorflow is an open source library for machine learning and artificial intelligence. And when you install Tensorflow, if you're installing the later versions like Tensorflow 2.0 and up, it's also going to automatically install Keras, which will be like a Python interface for the Tensorflow library. So we'll need both those libraries or modules installed. If you don't have them installed, you'll probably going to need to install them. And you can do that using pip install, and I could just type, in this case, I'm using a specific version of TensorFlow. So I specify TensorFlow 2.10, and I already have TensorFlow installed, so that's good. And then I could also just do pip install Keras, but since I have TensorFlow 2.1, it already has Keras installed. And then the last thing that we'll need is also have Matplotlib, which will give us a way of just graphing our output or results. And whoops, I think I did that wrong. Pip install Matplotlib, there we go. And I already have that installed as well. But you'll want to make sure that you have those libraries or modules installed. If you do, then we're good to get going and start jumping into the code of making a very simple neural network. So now we can start jumping into the code. So we're going to import our TensorFlow library as TF, and then also from TensorFlow import Keras, and then we'll also have to import our Matplotlib and then pyplot as PLT, so we can graph or display charts or graphs with our data to kind of give us a better idea of what the neural network's doing and what its output is producing. Now we're also going to import random, so you can generate some random numbers really easily. Again, what we're going to be scripting is we're going to be asking the user ourselves if the price of an item is expensive or cheap. Now we're going to build up a bit of a bunch of test data. Is $5 for a loaf of bread cheap or expensive? Is $8 cheap or expensive? We're going to ask the user a bunch of times, is different prices cheap or expensive for an item? And then we're going to use that data to train the neural network, and then have the neural network be able to be tested with these prices and output what it thinks is cheap or what it thinks is expensive. So to do this, I have to ask the user or myself a bunch of times, is this price cheap or expensive for this item? So we can build up some data that we can use to train. So I'm going to do maybe like a loop of like 10 times. And I'm going to ask, is a price expensive or cheap for an item? So I'm going to generate a random number. I'm going to do like a random number between, so a random integer between 1 and 10, maybe 0 and 10. And then I will ask the user. So I'll generate a random number called random num, and that will be a random integer between 0 and 10. And then what I'll do is I'll save the response of what I input as another variable. So response equals input. And I'll ask something like is random number, whatever random number it draws, is whatever random number it picks for a loaf of bread considered expensive or cheap. And then maybe we can ask the user like EXP for expensive or cheap for cheap. So I'll type in some words. So we'll do that. And that way we'll be able to ask ourselves 10 times, is this price expensive or cheap for a loaf of bread? Now, when we ask that, we also have to make sure that we record that answer. So what we're going to do is add an array as a variable. We'll create an array called xtrain, which will contain the data of the price of the item. And then we're also going to do a ytrain variable that will contain the classification of the item as expensive or cheap. So that's going to be the arrays or variables that store the training data that we'll use to train the neural network. And we're also going to create two more variables like xtest and ytest, which will be sets of data used to test the neural network. So our input will be stored for the xtrain and ytrain, and then xtest and ytest will just be data used to test the neural network. So now we have our variables. We're asking the user to determine whether a loaf of bread is considered expensive or cheap 10 times, and it's going to randomly draw a value from 0 to 10, and it will record that in our xtrain variable here. So that's the next thing that we're going to do. We're going to record our answer, xtrain.append. We're going to add to that our random number, and that way it's going to be building up that list of training data. And we're also going to have to append our answer that we specify. So we're appending the number or the price of the item, but we also have to append what we respond, expensive or cheap. So how do we do that with the neural network? Well, what we're going to do is we're going to say if our response, so if response is this here, if our response is exp for expensive, then what we're going to do is to our ytrain, our classification of whether the item's expensive or cheap, we're going to append something like this, 1 and 0. So that'll be classification as expensive. And then if we have a response that is cheap, we think it's cheap, then it's going to append data that's different, at 0 and 1. Okay? So that will specify that the classification of it is cheap. And why do we have 1 and 0 and 0 and 1? This is like the probabilities. There's two possible outputs, expensive and cheap. So expensive, cheap. Expensive, cheap. Technically, we could have these be like not 100% or not fully sure. Right now we're saying, okay, when we say it's expensive, we're saying it's 100% expensive, 0% cheap. And when we say cheap, it's 0% expensive, 100% cheap. You could technically have it be like not a fully solid answer. It could not be a totally 1 or 0 outcome. We could potentially have it where it's maybe kind of expensive or kind of cheap, but we're not going to worry about that for now. These are outputs, two potential classifications. One is expensive, one is cheap. If we say it's expensive, it's expensive. If we say it's cheap, it's cheap. So we're just going to keep it simple, but that's the reason why we kind of have this set up this way. Now, once we've done that, we're done with our for loop for the most part. We've collected all the data. We've generated all the data. We generate 10 price points for the item. We ask the user if that's expensive or cheap. We record all that stuff in our xtrain and ytrain variables. Now what we have to do is produce the neural network model and train it and get that all working. So the next thing that we're going to do is we'll define a model. So we'll do model equals Keras dot sequential, and we'll make 2 layers in our neural network. So we're defining our model here, or our neural network, and we're going to do Keras dot layers. We're going to add 2 layers. We're going to make a dense layer with 1 input. So input shape. There we go. And that's going to be our price. And then based on that price, it's going to have 2 layers, also dense, for the potential outcomes, expensive or cheap. And activation will be softmax. There's different kind of activation types you can use here. We're using softmax because that's going to work the best in this case, but in some cases you may want to change that. Softmax will pretty much turn this into a probabilities distribution. So it works well for what we're doing, which is just like pretty much like a classification problem. But there's many different other activation functions you can use. So that's what we're going to leave that at. And maybe I'll add some comments to the code here, because when looking at this, later on you come back to it, you might be wondering what exactly we're doing here. So I'm just going to throw in some simple comments here just to summarize this and go over this. So first layer is used to process our input data, or price of item. Okay. That's our first layer here. And then what we're going to do is our second layer is pretty much 2 units, because 2 potential outcomes. So we'll say 2 units used for classification of whether the price is expensive or cheap. So that's it. And that's our model. So we'll compile the model. So model.compile. Optimizer we'll leave as Atom. Loss we'll set to categorical cross entropy, which will work good for classification type problems. And then metrics, we'll set that to accuracy. And that should be it. So now we've compiled the model. Now we need to train the model on our data. So to do that, we'll now train the model. And to train the model, it's very easy. We just do model.fit. Take our data that we're inputting on xtest, xtrain, the data that we've provided with our answers, so ytrain. And then epochs we have to specify. So epochs is pretty much how many times the data is passed through the learning algorithm. The more you train it with more epochs, more accurate it will be in most cases. At some point, it won't get any more accurate and it'll kind of max out, but this usually has to be pretty high. We're just going to leave it at 1 for now, so I can show you what happens if we don't train our neural network enough. And then verbose, we want to output what it's doing. Yes, we'll set it to 1. So I'll put just a little bit of data of its progress. And then what we can do is test this neural network. So we've compiled the model, we've trained it. Now how can we test our trained model on data? So we'll pretty much copy what we did up here. I'll do a loop, but instead of 10 times, I do 128 times. We'll choose a random number between 1 and 10 as the price of the item. And we will ask the neural network, is that price expensive or cheap? So we'll get it to make a prediction. And that prediction will be model predict. It'll use the model to predict. And random number is what we're feeding it. And verbose, I won't have it do any output. And then we'll append that random number for X test. So random, and then we're also going to append the prediction of the neural network. So same as what we've done up here. Again, I can probably copy this, paste this, and just change a bit of this. So we'll do if prediction 0, 0 bigger than prediction 0, 1, something like that. So it's checking, is the predicted probabilities first element more than the second element? So is it expensive or cheap? Like, is the weight on expensive more, or is the weight on cheap more? So based on that, it will output whether it's expensive or cheap. So what we'll do is something like ytest.append 1. This is predicting that it's expensive. So we'll say print. We'll output the random number. And we'll say is expensive. And then we'll copy all this, do the same thing here. But we don't need an else if. We could just do else, because they're already checking here. Is it more expensive than cheap? If it is, it's expensive. If not, it's cheap. We only have 2 outputs, so it only can be one or the other. So I don't really have to check anything else. And if it's cheap, we'll append 0. So that's pretty much checking our prediction to see if it is expensive or cheap. And then we can just run this and see what we get. So I'm going to go here and I'm saving this, and I'll run this code. Hopefully I didn't type anything wrong. So it's going to ask us, is $5 for a loaf of bread considered expensive or cheap? I'll say it's expensive, even though it's not that bad. It's actually, you know what? We'll say it's cheap. That's not too bad. $6, that starts to get maybe a little bit more expensive. Let's say expensive. $0, definitely cheap. $1, cheap. $5, let's be consistent, say cheap. $3, cheap. Again, it asks $3, cheap. $7, that's expensive. $5, cheap. $6, let's say that's expensive. Okay, so what do we got? We got an error here. What did I type wrong? Input shape. What is wrong? Forgot that equal sign. There we go. My bad. Let's try this again. So, $8, that's expensive. 6, expensive. 10, expensive. Cheap. Oh, I gotta be careful because I typed with a capital there, so it's probably not going to get added properly, so I'm going to have to redo this. So we should probably do like error handling and stuff, but we're not going to worry about that for something so simple right now. So I'll do this again. $5, let's say cheap. 10, expensive. 6, expensive. 3, cheap. So I'll go through this 10 times, as painful as it is. We can also provide data as like a file that it loads. Probably a lot better than doing this, but we're keeping this simple. Okay, so here we go. It starts to run the neural network and train it. And again, we run into some errors. I should really just check this before we run the code. But it's pretty much telling me unknown categorical. Oh, I spelled that wrong. Categorical. And that should be good. So apologies for these minor errors, but this is kind of the stuff that often happens when you're coding. So let's not worry about it. If it's an error that we know how to fix, it's not a problem. So almost done. There we go. So now it's training. There it goes. So it pretty much says almost everything is expensive. Like we're seeing it says, okay, 0 is cheap, but it thinks 2 is expensive. But it's not. Like I've clearly said here, like 3 is cheap, 2 is cheap. Why is it doing so poorly when I test it? And that's because we only trained one epoch. And look at its loss amount, 5.8. It's not very accurate. You want to get that loss number down to a low amount, to a point where it doesn't really get any lower. Or you want to try to aim for that, because that's going to give you more accurate output. So right now, this is not working too well. So that's the reason why one epoch will never really give you that great of results. Instead, what we're going to do is train this 1024 epochs. And again, I know this is painful. You're going to have to watch me say if prices of bread are expensive or cheap again. But now we're going to train it with a lot more epochs, and it's going to give us much more accurate output. So is $4 for a loaf of bread considered expensive or cheap? I'm going to say cheap, expensive, 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 and so on. So almost done here. There it goes. Now it's going to train. Okay, there we go. 1024 epochs is going to go through. See how the loss number is getting lower? 0.3, and it keeps going lower. You want to get to a point where it doesn't really get much lower. And then you kind of know you've reached a point where it stabilizes or kind of maxes out. Now, there's a lot better ways to test this. It gets more complicated than that, than just trying to get this number to a lower amount. But now you can see the output's a little bit better. It's properly, or more properly, specifying if things are cheap or expensive. It thinks 1 is cheap, it thinks 6 is expensive. It thinks 0 is cheap, it thinks 10 is expensive. Now, looking at this output like this is not the best way of viewing this stuff. It'd be great if we could graph the outputted results so we can see at what point does it think things are expensive, at what point does it think things are cheap. So what we're going to do is plot this. So we'll use PLT or Matplotlib to create a scatter graph with our X test data and our Y test data. And we will set our Y test, as the bottom graph. So what I'm going to do here is PLT X label price for a loaf of bread, and then PLT Y label cheap being 0 or expensive being 1. And then we're gonna, we're going to show that graph for that chart. So I'm just adding that so we can actually graph predictions of neural network, so we can get a better idea for what it thinks is cheap or expensive. And we're going to run all this again, and let's hope this all works. Let's test this out. Here I go again. It's testing me. Okay. So I'll input all this. Takes a lot more concentration than I expected to answer these. But there we go. Now it's training. 1024 epochs. Probably a bit more than we really need, but let's see what happens. So there it goes. All the way. And when it finishes now, it's going to test it. 128 times. It's going to show us a graph. We'll get a better idea of what the neural network considers expensive or cheap. So at the very end now, it's going to display a graph to us. So here we are. And we can see that it says pretty much it thinks anything above 3 is expensive, anything lower than 3 is cheap. And you can see here it says 2 is cheap, 3 is expensive, and this is going to be based on the values we gave it and what it learned from that. So there we go. We now have trained a neural network, and you can give this a try, see how it goes. And you have to be a little bit careful because if you don't close your command console and stuff, it might not actually clear these variables. So maybe at the end of this, we should just delete those variables so it properly clears our training data. Normally, you probably store this as like files and stuff, but you just don't want to have that data stack up and cause a problem. So I'll do this one more time, and we'll see the output, see if it works. So $7, let's say that's expensive. 6 is expensive. Let's say anything lower than 5 we consider cheap. 7, expensive. 8, expensive. 3 is cheap. 10 is expensive. 2 is cheap. 8 is expensive. 10 is expensive. 3 is cheap. So it never really asked us, like, is 4 cheap? Is 5 cheap? It'll be curious to see what the neural network thinks. So depending on what it asks you as well, the data may sometimes be better or worse. We'd probably want to ask the user more than 10 times. But again, we're just doing this as a simple example. And again, here's the output. Goes through all of it. Shows us our chart at the very end of testing it. And again, there we go. It's not too bad. It thinks anything around 4 or higher is expensive. Anything less is cheap. So that's pretty much setting up and training a very simple neural network. I know this is very basic, but at least now you have an idea how to do this. If this interests you and you want to start seeing more of tutorials like these that deal with machine learning and neural networks and deep learning and all that stuff, let me know and I can start making some more where we start to classify images or shapes or other things and start adding complexity upon what we've done today.